Good morning. Good morning.
Did we start the trial? Time, huh? Oh, students, let me check. We have Dr. Memoli here.
Good morning,
Think we should-
colleagues. How are you,
Look here.
Prof. Fairs and Dipendra Awal?
No, I mean the mouse. Here it is. I think it's extended. They do it as an extended screen. Good morning, everybody. And welcome back and Happy New Year. I hope you are refreshed and ready to start another new semester, new spring semester 2024. So we are up and running. So hopefully that you're staying warm and nothing serious about freeze and, breaking pipes and other. Hopefully I didn't hear many stories, so that's good news. So that means we are adapting to extreme weathers. We also welcome our online also attendee. We're getting there, so the seminar schedule is getting populated. So we still have few openings. So if you have some recommendation, please feel free to do so. Before we start, I would like to, on behalf of our dean, to make this announcement on the workshop he shared with us on the workshop opportunity. It's called Building Sustainable Solution to Tackle the Climate Crisis. This workshop will be Friday and Saturday, the 19th through the 20th. Friday is evening time and Saturday is almost entire day from 8:30 to 3 p.m. So it's going to be in our Ag and Business Building, room 114. You're familiar with that room. The workshop is open to faculty and students from all disciplines and stages. There will be dinner as well on Friday, and on Saturday there will be breakfast, lunch, and snacks. So don't worry about food, just come and participate. In addition to breakout sessions for teams and 10,000 in prize money. So there is some money there. There's a big incentive that you don't want to miss. The foundation of the workshop is a mini design thinking course organized by the Center for Innovation Entrepreneurship. I think it's for the College of Business, right? So, and you're familiar with the instructor. He gave us a seminar last semester. So please consider participating. For today, it's my pleasure to introduce to you our colleague, Dr. Jenny McClurkin-Moore. She is an assistant professor at Texas A&M University, Department of Biological and Agricultural Engineering. Is at the forefront of post-harvesting biotechnology. She is a product of HBCU, where she got her BS in North Carolina A&T and bioenvironmental engineering. Also, she got her MS degree from Purdue, West Lafayette, and also her doctoral degree in the same area of ag and biological engineering. Dr. Moore oversees the extremely successful post-harvest engineering and education research program at TAMU. Her innovative research includes oxidative depolymerization of lignocellulosic biomass, mold and mycotin inactivation in stored grains, and unique education methodologies for biological and agricultural engineering students. She is a pioneer in the application of ACP for grain and oil seed treatment, addressing crucial challenges such as mycotin inactivation, heavy metal uptake, and waste valorization. Dr. Moore research interest encapsulate post-harvest treatment technologies, shelf life preservation, mycotoxins, food safety, agriculture biosecurity, agriculture terrorism risk assessment, storage and packing methods, and design-based research. Her multi-facets contributions define the future of sustainable agriculture and food quality development, embodying the essence of trailblazing post-harvesting biotechnologists. She's co-PI with us on several projects, one REU that we are finishing, and Get Ag Smart that she's part of it. Also, we're collaborating on other pipeline projects that we're working on. So she's also looking for opportunity to collaborate with rest of you if you are interested in this area of her research. With that, I would like to welcome Dr. Jenny Moore. She's going to be talking to us about food, feed, safety, and renewable energy. Welcome back.
Good morning, everyone.
Good morning.
So as you can tell from that bio that Ali read, I'm preparing to go for tenure, so I have to make sure I sound amazing. And
You are.
make sure that I'm leading and the greatest. And so, but today I'm so honored to be here at Prairie View. Since I've been at Texas A&M, I tried to make sure I make a stop here once or twice a year, whether it's speaking with the students in the NSBE chapter or the Manners group, or just working with our REU that we were on before. It's a very nice place to come back to, and I feel very comfortable on this campus. So, but today I want to share with you a summer research opportunity that we have at Texas A&M. This is an extension of the work that we had been doing for our REEU the past 3-4 years. So previously, we were on a grant working on a water reuse summer research program. And so through that, because my research is in food safety and food security, and we know the importance of the food, energy, water nexus, what we did was we expanded that research program to integrate food and feed safety and also the renewable energy. So now we'll get an opportunity for students to not only have the experience with water reuse and the importance of water, but taking that and utilizing it in our food production and making sure that food is safe and as well as feed, and then the energy inputs that go into that, so we can just work through that whole nexus. So they already told you a little bit about me. I am a product of an HBCU. I went to North Carolina A&T. While I was there, I had an internship with the Department of Homeland Security, and that allowed me to do some really top secret stuff that I cannot talk about, but you know, if there's ever an emergency and I say, follow me, just trust me, follow me. So I then went to Purdue, and while I was at Purdue, I received the National Science Foundation Graduate Research Fellowship, and that's what allowed me to finish my PhD. My plans were always to become an attorney. I wanted to go to law school. I was gonna take my engineering degree and then turn into like a tree hugger, save the trees type of attorney. But with that NSF fellowship, it gave me the opportunity to complete a PhD. And then I really saw that my passion was in working with the next generation of youth or next generation of engineers, specifically in the agriculture area. And so this REEU, this research program, is like my one of my goals in life. Another goal I had was to graduate with PhDs and masters, minority students. And so thankfully I've been able to graduate some a master's and a PhD student, both from diverse backgrounds. I've got a couple others too, but it's kind of like when you see all the pieces of your life coming together. It's kind of the stage that I'm at right now. But moving forward, so my research team is called FEED, so Post-Harvest Engineering and Education, because all of the work that we do is focused on making sure that we can feed the world, right? We're expecting those 9 billion plus people by 2050, and that number is moving around year by year, but often people go hungry. There's so many people in the world, the population's increasing, and then we need to be able to provide food to these people with all of these different types of dietary needs. But one thing that we see across all of the different dietary needs is that everybody has some type of grain involved in their diet. And so that's why my research focus is primarily on grains and oil seeds, because what y'all eat for breakfast this morning? Cereal or, something related. You might have had some type of oatmeal or grain there for breakfast. For lunch, you're probably, you might have a sandwich or something. So I just really feel that this is an important area for us to be able to work and to sustain in order to feed those the people that are coming. I don't know what I did. Okay, so I mentioned this earlier. We have the food, energy, water nexus. So this comes from the work that we're doing with the Smart Ag project. But digital agriculture combines multiple data sources with advanced crop and environmental analysis to provide support for on-farm decision-making, but not just on-farm decision-making. When we move grains from the farm to be processed or to be stored, we also have a component of data collection that is occurring that we need to be able to monitor and analyze. So I also teach our first year engineering course, which is focused on Python programming. And so I try to instill in my students that the programming that you're doing, what you're learning how to compile and put together is not just useful for making an AI robot or a machine to do something for a car or whatever they might be thinking of, or to create ChatGPT. But it's also important for us for making sure that our food stays safe while in storage, right? Because if we harvest things at the right conditions and we get it out of the field, but then we store it in somewhere where there are bad conditions or unfavorable conditions, and microbes begin to grow, CO2 increases, the moisture increases. What are some ways that we can monitor these things and collect that data in order to make sure that the grain stays safe, the food stays safe? So I try to move them beyond just thinking about what's happening at their computer and go to what the world needs. What can we do to make this a fully integrated system to make sure things stay safe and we're able to maintain our food supply. So this is just the image that I like to use when I show my students about how far digital ag goes when it comes to programming and things. So you see the UAV and it's collecting the images and just showing them the importance of that. Then I take them to some programs that we like to write. So this is a Twitter sweep that we did. And this Twitter sweep, what it does is it goes out and searches X, because that's what it's called now. And you can put in a keyword and it will go through all of Twitter and find that keyword, pull out all of the tweets that relate to that keyword. And then we can go through and do some analysis about and see what people are saying. So if you wanted to know what happened with the freeze in Houston, if anybody was tweeting about it or Xing about it, is that what we say now? I don't know. Then this will pull all of that information in. So it's kind of like we have these tools, we know we have this need. How do we connect them and find out what the people are looking for, what people really need help with, what people really want, and then how do we develop, or how do we integrate our research and our tools to make people's lives better? So that's what I like to show the students. And then of course, we've all seen lots of digital ag images. I'm gonna skip through that. But what we really need is a way to prevent, detect, and respond to foodborne illness outbreaks or foodborne issues. And that's what our research is mainly focused on. It's like, if there's a need, if there's something, someone starts tweeting about their stomach aches, their stomach issues, and they ate this, they went to Chipotle yesterday, and we keep seeing trends with people going to Chipotle and then having a stomach issue. And then all of that comes just the same way that USDA and everybody gets that information. We can also do other searches to kind of see what's happening in the real world. Is this about to result in a foodborne illness outbreak? And so just to be able to kind of think about what things people might say, what might be out there, and what are some of the issues you might see, and then how do we treat that? What do we do, right? So this leads me to our summer program, and I'm going to talk a little bit about this project. I've got this slide coming up again because if you're working with undergrad students, freshmen through juniors, who are looking for an opportunity this summer, we would really love to have them come to participate in our program. But it is called FRESH. It's the Food, Feed, Safety, and Renewable Energy Summer Hands-on Research Experience. And it is a 10-week summer internship program for students in the ag area interested in the more technical side of things, but we really focus on food safety and renewable energy. We do give them an $8,000 stipend for the 10 weeks. We also provide them with housing. We provide them with travel and with a meal allowance. So it is very well thought out program to make sure that the students' needs are met. Why? Because I was that student in the summer looking for an opportunity, trying to get the research experience, but still having to take care of my responsibilities and things. So everything is covered, everything's taken care of. But what we are doing through this program is, oh, that's kind of small. Okay, small up there. I'll turn around this way. What we are doing through this program is we have our research projects, and I will go into detail about each one of those projects in a minute. But we also are doing some leadership development, and that's through each week we have a different program where we integrate some key concepts for leadership. We do a career exploration and mentoring through Texas A&M. We have a summer program where they always bring in somebody to speak to the students for the career exploration. They work with them with the GRE and applications to Texas A&M for grad school. And then there's a mentoring component. The mentoring component comes from my end. So we have a mentoring plan where the students are set up with the faculty who are part of the program, but it's not just like this faculty is giving you orders or giving you instructions for the research to do. They actually sit down with you and talk through, what are your interests? Why are you here doing this research? And try to give them some valuable key things that will help them throughout the rest of their career. We also have a summer publication that we end up with, and we do go and present, the selected students go to present their research findings at our national conference. But the most important part about this is that we're building a community of scholars. And so through our last REU, what we did was we started a LinkedIn page. And so that LinkedIn page connects every cohort of summer students with each other. And so now when students are moving on and they have their careers, they can reach back to that cohort, to the other cohorts, and say, hey, anybody interested in working for Syngenta? Anyone interested in working for, this company? We have these opportunities. I know you're part of this program. And this is available. It also allows so one of the things I do is I have the previous cohort write a letter to the next cohort and tell them, like, this is what you're going to expect. Dr. Moore's a little loopy, this person is, like that, or you'll have fun when we go to visit the farm at Prairie View. And so they kind of tell them what to expect. And so we have a good time with the next group of students as they read through those and look at all of the keys and suggestions that the previous group does. But we really try to bring this classroom lecture, hands-on research, put that together, and then push that out to the social media as well. So students will take their research projects, and at the end of the summer, they create like a 60-second TikTok style explanation of their research, and then they push that out to all of our platforms. So now we don't only have it on LinkedIn, but we're able to put that out on Twitter and on Instagram and Facebook. So more than just the students have access to that and can get a little brief knowledge of the work that's being done. So our program is focused on food and feed safety and renewable energy. They are all interconnected in some way. So we break it down into post-harvest processing and then biomass processing. And then for the post-harvest, we're looking at fresh produce, so leafy greens. Again, that Chipotle outbreak, we always have something coming up at Chipotle. And then how can we reduce those microbes from those types of outbreaks, but also grains and oil seeds. Ali mentioned mycotoxins a lot in my bio. Mycotoxins are secondary metabolites from the fungi that's like in the field. So if there's aspergillus out in the field, comes into being in the storage unit, gets metabolized, we have aflatoxins. Aflatoxins are at high thresholds, very dangerous to our ruminant animals, definitely to humans. And we see a lot of issues with chickens and things with those. And that's not just in grains and oil seeds, but we also see those in like peanuts. Biomass processing. So how do we process this for animal feed or for biochar and bio oil? And then what I'm going to talk about in a second is our cold plasma system. And so how do we use that cold plasma system maybe for hydrogenation of the oil? So to create additional carbon chains there, or to oxidize and depolymerize as well. So here's the system. Let's see. I didn't test it out beforehand, but let's see. What did I do? All right, so that's the atmospheric cold plasma system we work with in the lab. It's a clear image of it there, but I wanted you to hear it because what you're hearing is the ionization process that's occurring with the plasma system. So this system is a high voltage system. We get we normally operate at about 80 kilovolts. So you'll want to keep back from it. But we take a high voltage transformer, we have a controller on it, and then we run that to our electrodes. And between the electrodes, you have your dielectric barrier, which is just like a plastic cutting board kind of, you see it there. And you have your sample, you have your package, and your ground barrier, and then the ground electrode. So it's happening with the cold plasma system. Y'all know I could talk about it all day. Okay, so I had to check my time. What's happening with the cold plasma system, I call this lightning in a bag, right? Because it kind of looks like lightning, and plasmas are like lightning. And so we keep it in the package, or we keep it in the bag, because the gases that are inside of the package are very reactive. So you start off with just like air or oxygen, and you fill the bag, seal it, you turn the system on, and the voltage as it runs through is ionizing the gases that are in between the package. And so if you have like pure oxygen there, you ionize it and it becomes ozone, right? If you've got, there's over 3,000 species, that reactive gas species, that you can create from this system. But what we want to do is we want to engineer the system. So how long do we run the treatment? What size package do we use? What size bag do we use? What voltage do we treat this at? In order to get the most optimal treatment for the product that we have. So that's our system in a nutshell. I would love to show you all of it in person if you ever want to come to Texas A&M and check it out. Or we also have a mobile system that we eventually want to start using in the field, that we can just carry around, and does kind of like a pinpoint laser. Oh, the other thing I compare this to is like a lightsaber. So any Star Wars fans, that's basically a plasma also. I mentioned oxygen and ozone. This is not like the ozone that's bad for the ozone layer. This is here at, and we keep it in the package, by the time it comes out of the package and kind of gets into the space, first of all, you don't want to be around there because it is still reactive gas, but it'll break back down to oxygen. So it's not depleting the ozone layer there. But this is another look at our system, and kind of another way you can get. So my plasma, depending on the electrodes, we get different results. So, okay, so the research projects that we have going on for the REEU are, one, to predict the effect of ACP, or atmospheric cold plasma, on the inactivation of microorganisms on the surface of fresh produce. And Dr. Moreira works on that project. And so she'll be looking for 2 students for that. And they'll be doing a lot of mathematical modeling for that. The other one is to predict the effect of cold plasma on the physical properties of whole and ground grains and oil seeds. And Dr. Castell is working on that. I see what I did. Dr. Castell is working on that. And then Dr. Caparetta is doing understanding of bio oil and biochar production and modification with cold plasma. So we have already done some work with cottonseed and cottonseed oil, and we saw that we were able to transform we increased the we were able to change the fatty acids that were in the cottonseed oil. I could pull up the other presentation. I don't want to lie and tell you we did one thing one way or one thing the other way, but we wanted to see if this cold plasma was even having an effect on cottonseed and cottonseed oil and the fatty acids that were coming from that and produced from that. All right, so that's all I have for you. Thank you. But I am open to questions. If you have any questions, if we have time.
Yes, we do have a question. I think we'll start from the online. Our executive associate, Director of CARC, he has a question. Dr. Erdogan Mimeli. Dr.
Yes.
Mimeli, you go ahead, please.
Yes, good morning. Can you hear me? Yes, can you hear me well?
Hold on, we gotta get the sound coming in.
Hold on a second. Let's work out the.
Yeah, I will type it here. Can you, if you can hear me, let me know.
Yeah,
Can you hear me well?
loud and clear.
Excellent. Hey, good morning, everybody. Thank you. I had a meeting that got delayed and I couldn't make it in person, but great presentation. Doctor, thank you so much. Two brief questions. Could you perhaps have this last slide printed PDF and our undergraduates can receive? Second, I'm wondering if some of those projects could be sort of explored in a collaboration with our faculty here, because we have prominent researchers in similar areas that can involve in these REU projects. If students can kind of catalyze the projects and any kind of collaborating opportunities, I'll appreciate if you can elaborate. Thank you.
Yeah, absolutely. Thank you, Dr. Mamili. What we can do is we can even set it up to where for a couple of weeks, students are physically here and coming and working with the faculty that are here at Prairie View. That will be very easy to do. And for us to make those connections. And again, this is the first year for the food and energy one. We still have, this summer will be the first summer. We still have 3 more summers after that. So lots of opportunities for collaboration for this. Thank
That
you.
is great. Thank you. And we could
Any
also,
other question
he
from
said
the
he had
audience
a
here?
follow-up. I think he was.
Oh, here's a follow-up.
thank you. I was going to say, Ali, that we also have IISC here and great ways to make this program visible. We can help you with publications and all those things that are important when you apply for renewal of these type of programs. Thank you.
Yeah, thank you. Absolutely. And I failed to mention that our target is to have at least 4 students from Prairie View as part of the program. So, yeah, thank you.
Great, thanks.
Okay, I think we have a question from the audience here, at least one so far.
So my just talking into it.
Maybe introduce yourself since.
Oh, sorry. Yes. So, Dr. Jennifer Quinlan, new first day in person here. So glad to be here. And really excited that there was an in-person seminar on food safety today. That's my background, food safety and food access. Yeah. Thank you. Thank you. Yeah. Well, and what I didn't realize, and so first, great presentation and really great opportunity, students. If you have an opportunity to take advantage of it, sounds really wonderful. But really exciting to me is cold plasma, because as I mentioned to you, I actually have worked with cold plasma in poultry. So I'm just curious, your cold plasma unit, what size sample do you, so does your sample actually go into the middle of that unit? Like what size are you looking at this point?
Yeah, that is a great question. So we switch out our electrodes depending on the size of product that we need to treat. This is the one that we use most often. And so it is literally just about, 4 inches high. So anything we could, we could fill the whole bag, but adjust the treatment perimeter so that we get treatment throughout. But we also have some larger electrodes where we can treat a like storage gallon container. We also adapt it to a conveyor belt to get a variable plasma treatment going through there as well. And then we have a rod that we use for liquids. So we've done some work with treatment of milk as well.
So you could get a chicken in there.
We can get we can treat a chicken.
Yeah.
We can treat not alive though.
Don't
But
zap it. Don't zap it or it is alive.
Right. Yeah. But in your work, were you doing like the whole chicken or just like chicken breast or?
We were doing chicken breast and just spot. We had we had like a wand that we just put it over, but so we didn't have anything you could put it in. So
okay. Yeah. So we could easily fit a chicken breast in there.
Yeah.
In this system. For the whole chicken, I'd have to make some adjustments to it.
Well, and ultimately you'd want the conveyor belt, right?
Right.
Yeah.
Right.
So
Yep.
that's really neat.
Yeah. And there's really only been one, I've only seen in industry one system taken from the faculty I used to work with at Purdue, and he got it commercialized and for a conveyor system, but it was kind of different. It was bag lettuce, and they had it like clipped on this conveyor, and then it would move through a wall of electrodes and go through. But that was just for bag lettuce. That's the only place I've seen it. So,
Yeah, neat. Thanks.
thank you.
Thank you. I think you had a question. Yeah, you have a question? I'll be surprised if you.
Is that right? So thank you for giving that presentation. My question is, my research team works in my research team, I should say, Adisi and I, right? Okay, we work with nanomaterials, and so we are looking at nanomaterials for food safety applications. Just wondering if you would be willing to test some of our nanomaterials using cold plasma.
Okay, yeah, so we would be willing, which nanomaterials? I've worked with like zinc oxide nanoparticles before. And you know, they kind of give that same oxidative effect sometimes on the surface of things. So I would definitely be interested in trying to see how cold plasma affects or enables or increase or even combination treatment effects of those as well. So
okay, yeah, there is some zinc oxide, there's zinc, there's silver
okay,
base material as well.
okay,
Yeah.
yeah, absolutely. So how do I make sure that I connect with everybody? Like, do I get?
So you have is your email up on?
My email is, I got rid of the slide.
Okay, that's fine.
Yeah, okay. I hid it.
Just go ahead. No one would thinking about having an office for her here. Absolutely.
Yeah.
Cyprus, so it's.
I do, yeah, yep.
We also have products like nano composites,
Okay.
not only the metallic or metallic oxide form of nanoparticles, but we have also organic matter, nanomaterials conjugated metal, so we can try all those kind of products
Okay, yep,
for post harvest.
absolutely,
application.
yep. Love that.
I have a question.
Sure, go ahead.
Okay.
Since you have it.
Yeah, I'm sorry. Do you have any experience in meat products, like patties? Okay, sorry. If you have any experience in meat products like patties or hams or raw beef to pass with when you apply antimicrobial and pass for cold plasma?
So there's been some work on it, but I haven't done any work on it. But the system could, like, I look at this cold plasma system as a vehicle. And so whoever wants to jump in and try and test and work with it, I'm very open and willing to try to see what we can do. My thing that I like to do is, I say it all the time, engineer the system. So I'm an engineer. I want to model the results that we get, make sure that we can have the most effective things, but whatever it is that you want to treat or take a look at, you know, I would definitely be open to and willing to look at that. There's a lot of reactive oxygen species, reactive nitrogen species. And so what is going to happen to those biological products in the system? We found that you don't get, like with the grains and things, we did not change the amino acid profile. We didn't have any effects of the quality of the grains and oil seeds, but I don't know what that looks like with some of the meats and things as well, but I'd love to research that. Yeah.
Other questions for Dr. Moore? Okay, yes, Dean.
Yeah, several comments. Janie, first of all, thanks for a really terrific presentation. Clearly, just from the 30-minute presentation, I can tell you're an outstanding teacher. And so I feel sure that you will sail through tenure and promotion. All the best with that. But also, question that I had, suggestion is, we've been thinking about a concentration area at the undergraduate level in ag engineering or biological and agricultural engineering, not necessarily to compete with you folks, but really to complement each other, because we deal with underserved students and limited resource audiences and quite a bit different. But the one who came up with this idea is actually the dean of our engineering school. And I thought it was a fantastic idea, and I proposed it to my curriculum team. And so there seems to be a lot of excitement about that. So that is on our wish list, is to help us with at least a concentration area in this emerging field of biological and agricultural engineering. Many in the audience have engineering background, engineering degrees, and so on. And I think ag is a natural home and vice versa. So very pleased that you're here to kind of synergize and coalesce all of the great expertise here on campus, and especially in this audience. And some of our folks here are very humble. Dr. Carson, for example, she has a team with about 20, 30 undergraduate students as well.
Wow.
So don't
That's
forget
amazing.
them. Yeah, so that's part of your
Yeah.
team, because you're inspiring them to become scientists and so on. But also in our audience, there are folks who are working on cures for cancer, diabetes, Alzheimer's, so on. So there's a lot of accomplished folks here and a lot of great expertise. And now with Dr. Quinlan here, director of our Food Security Center, I think we're poised for many great things. So really not a question, but very enthusiastic to have you as our opening speaker for the spring semester. And great to have you on board. And yes, Dr. Memley, let's figure out some office space for Janie down the road. It's a natural stop between Cypress and College Station. So thanks, Ali.
Of course. Thank
I
you.
was telling her that sometimes if you have a need for a space or so, and she's a copy-eye with us, so I've been working, so we will accommodate that. So I'm glad you, yes, that's what I mentioned as well, so. Okay, good. I think, any other question for Jenny? And by the way, we have several ag engineers here. She's active in the Ag Engineering Society also. We have Anoop, he's ag engineer. We have Atakur, ag engineer. Myself as well, I'm an ag engineer. So he's a mechanical engineer, but we can accept him as an ag engineer. Okay, so anyway, any other question for Jenny? That would be she's active also on other projects that we have as well. Get Ag Smart, which basically it's about teaching smart agriculture to students and also professionals. It's an active project that we have been doing. So I think if you remember a year ago, this time, it was January 29th last year, where we had that day where we invited people from the industry, and we had a discussion about what type of curricula do we need in smart agriculture.
Yeah.
So that project is still going, and she's a component. She's an important person on that project. In fact, part of that is to include some modules about smart agriculture in our current work, and I think I wish you had time to show some of the product that your student did contribute as part of that project. So
but I was going to say the other part of my research team is focused on education, right? So it's FEED, it's post-harvest engineering and education. So I also do a lot of engineering education, educational assessment, and then developing the learning modules as well. So,
but anyway, I think if you don't have any question, she's around the road here in Cyprus, and we'll look forward for more collaboration with her across the disciplines that of interest to her and to you. Thank you again. Have a great day.
thank you.